Alright, back again. May 2015 IB SL Maths. This is paper 2, time zone 1 for the May 2015 papers. We've got a function here, the log of 4x divided by x, defined over the domain 0 to 5, x greater than 0, less than or equal to 5. The point P is at 0.250, so they've given us the x-intercept there. Nice. And Q are on the curve, the tangent to The tangent to the curve of f at P is perpendicular to the tangent at Q. Find the coordinates of Q. First thing you're going to want to do, you don't need to do this first, but I would get it on your calculator and have a look and see what it looks like. That's on the standard view. You can see the standard view is okay. Some of you like to use the zoom auto. If we do that, it's not my favourite view. It's workable, but I think given that they've given us a domain from 0 to 5, you can either set it from 0 to 5 or maybe even just -1 and maybe go as high as 6. That should give you enough of a view. The y coordinates, you can see what it went up to there, so maybe we just make them nice round numbers, -3 to 2. That should give us just a little bit more space above and below. Should look a little bit nicer, so we'll see if that has done the job or not. Exit, draw. That looks nice. We can work with that. So, we want to know the tangent, the coordinates of Q, and all we're given is that the gradient is perpendicular to the gradient at the point 0.250. So we're talking gradients, we're talking derivatives. So I'm going to let f of x equal u over v, where u equals log of 4x, and v equals x. Okay, we can go ahead and find the derivative of each of these now. Where's my pen? There it is. Couldn't quite see it. It's a really small little dot. So, derivative of the log of 4x is 1 over x. Yes, it's 4 over 4x, and then the 4's cancel, so that's 1 over x. So that's u dash. V dash is 1, and v squared is x squared. We can go ahead and use our quotient rule now. F dash of x, u dash v minus uv dash over v squared. Fill in the blanks. U dash v, 1 over x times x is just 1, minus u, log of 4x, by v dash is 1, so minus the natural log of 4x, divided by x squared. That's f dash of x. So, what is it? F dash at 0.25. 0.25 is a quarter. Now you can use your calculator. Probably not necessary for this one because you're going to have 1 minus the log of 1. 4 quarters is obviously 1, so 1 minus the natural log of 1. Natural log of 1, of course, is 0. Divided by a quarter squared. And we do that and we end up with 1 over 1/16, which is, of course, 16. So that's f dash at 0.25. What does that let me conclude? F dash at the x coordinate of Q is equal to 1 on 16. And it should be negative reciprocal, so we've got negative 1 on 16 there. Remember, perpendicular lines, the gradients are the negative reciprocal. You could even write that in just to make sure you're giving good communication there, making sure you're not giving away marks. So f of x for the x coordinate of Q is equal to -1 over f dash 0.25. Okay, so now I just have to find where is the gradient equal to -1/16. And that will let me find the x coordinate. Let f dash of x equal -1 on 16. What does that give me? 1 minus the log of 4x divided by x squared equals -1 over 16. You can try and neaten that up if you like. I wouldn't be risking making a mistake accidentally doing that sort of thing. I'm going to exit and we're going to put it in here. So we want 1, I need my brackets first. Make sure I get that whole numerator together. 1 minus the natural log of 4x. There it is there. That's divided by x squared. Now I could just do that and find where it equals -1/16. Let's do it that way. And I only want to look at one of them at the moment, so I'm sure there's a way to turn that off. Maybe that did it. I don't know. Let's have a look at the drawing and see. Oh, they're both on there, but that's okay. I want to find, so I want to go Shift G solve, and I want to find when this equation equals -1/16. So I'm going to G solve, find the x when y equals, so I've got to tell it which line. That's the line I want. Enter the value, -1 divided by 16. And that gives me x equals nearly there. So you can include a sketch if you like, or on calc use GDC, graphical display calculator, and x is equal to, and we ended up with 0.700750. Yeah, 0.700750. We can now find the corresponding value for Q, for the y coordinate of Q. So again, we're going to do a G solve, graphically solve. This time we're solving for a y value in the first function. Yeah, that's what we want. And enter the x value, 0.700750. Remember the recommendation, at least 6 decimal places when you're doing these calculations along the way through. And we've got a y value of 1.47083. So we can communicate that nicely. F of, this was xq. F of xq, rather than running out that whole decimal, equals, and it was 1.47083. I think that was going to be a 9. 1.47083. Oh, that's 6 significant figures, that's fine. Doesn't matter if we go even further. 0.83. Yes, it would have been a 9. That's good. So, what does that give us overall? Find the coordinates of Q. Well, we're done, aren't we? So, therefore, Q is the point. Now we can go to the 3 significant figures. It's our final answer. 0.701, 1.47. And we're done. Not too bad, hopefully. Alright, auf Wiedersehen. Catch you later. Bye.